In this video, I'll be working out the Chapter 7, Day 7 notes, which is over solving logarithmic and exponential equations. Number 1, we have learned that if we have an exponential equation, we should try to get bases to be the same. So, if I can get both of the bases to be 2, which I can drop those bases and say x minus 1 equals 4, and then I get x is equal to 5, and there we have it. So if bases can be the same, go ahead and go that route, and then solve for x. But you'll notice on problem number 2, it's going to be very difficult to get 7 and 20 to be the same base. So back in day 6, I had to give you some starting values in order for you to maybe solve for this on your own. But today we're going to do something different. We are going to take the log on both sides. So if you can't get bases to be the same, take the log, and I'm using base 10, take the log on both sides. Now I do this specifically for moving the power out front. I can only use the power out front when I have a log. So this would be 3x times log of 7 equals log of 20. I am then going to divide to get x by itself. I'm going to divide by 3 and the log of 7 on both sides. And if you notice, those would cancel over here to get x by itself. So I'm going to have a calculator here for this. Here's my calculator. So the way that I type this in, very carefully here, you're going to do log of 20, close parentheses, divided by, open up parentheses, 3 times log of 7. You'll have to double close those, and you get around 0.513. So here's basically the lesson for some of these. If you can get bases to be the same, do it. If you can't, take the log on both sides. So for problem number 3, before I decide any of that, I'm just going to divide by 2. So this would be 3 to the 2x is equal to 80. Now if that 80 was an 81, I might be able to get bases to be the same, but they're not, so I'm going to take the log on both sides. And I do that so I can move the power out front. So this would be 2x times log of 3 equals log of 80. Once again, I'm using base 10 because my calculator can do base n. And since my calculator can do base 10, it makes this calculation very easy. Then I'm going to divide by 2 and by log of 3. Make sure you put the denominator in parentheses. So x is going to equal, I'm going to grab my calculator here, so I'm going to take log of 80 divided by, close parentheses, divided by 2 times log of 3. Close. 1.994. So it doesn't specifically say where to round your answer. I would not want to put an answer of 2 here because 2 is definitely not going to give you this answer. That would probably give you 81. So I would use 2 or 3 decimal places each time. All right, so if I go down to number 4, similar to what happened on number 3, I had some steps to take care of first. Here I should subtract the 4, and then once I subtract the 4, sorry, that should be an x, I should divide by 2. And so I get e to the x is equal to 5. Now, if the e was like a 5 or some factor of 5 or multiple of 5, I might be able to solve this by hand. But I don't know what number takes this decimal and changes it to 5. More than likely, it's a decimal itself. So I'm going to take the log on both sides, but specifically, because I have a base of e here, I'm going to use the natural log on both sides. So I only use the natural log when the e is already present in the problem. If not, I usually go base 10. So take the natural log on both sides. So I'm going to move this power out front. So I get x times the natural log of e equals the natural log of 5. And the really nice part about using the natural log is I actually know this answer already without too much work, but I'll just remind you that the natural log of e to the first power should just be 1. And there it is. So x times 1 is just x, and then you can type in the natural log of 5 into your calculator to get your final result. So the natural log of 5 is 1.609. So problems 1 through 4 are giving you a picture of exponential equations, and specifically 2, 3, and 4 show you what to do when you can't get bases to be the same. So when I move on to number 5 here, okay, these problems are a little bit different than the ones we just did. So there's just kind of a separation here in the concepts, because now in number 5 they already put a log in the equation, so there's no need to use additional logs to solve. So these might not be as tough or need to show as much work. For example, number 5, the base on this log is 10. The power on that 10 would be 2, and I would set that equal to 2x plus 4. We've actually seen these problems before, so this would be 100 is equal to 2x plus 4, and then you just solve that for x. Now the hard part is when it comes to logs, you need to check your answer. And the reason why you need to check your answer is because you cannot take the log of 0, nor can you take the log of, let's say, a negative number. So I want to make sure that doesn't happen. So if I put this 48 back in, make sure when you multiply it by 2 and you add 4 that it's not a 0 or a negative number. Okay, so all I'm going to do is just real fast here, just think about what this is. 2 times 48 is 96. 96 plus 4 is 100. And I can take the log of 100. That's no problem. And actually, if I take the log of 100, I get back 2, which is what I have here. So I do need to check when the problem has a log, because I don't want to take the log of 0 or a negative number. So to convert number 6, ask yourself, what's the base on the natural log? Raise that to the 5th, set that equal to 4x. The only thing to get, or to do to get x by itself, is divide by 4. So this is e to the 5th divided by 4. I'm going to type that into my calculator. So that would be second ln to the 5th. Close that parenthesis. Definitely got to close that. And then divide by 4. So that's 37.103. And so if I plug that in and multiply it by 4, that's a positive number. Let me take the natural log. So natural log of 148-ish. It's going to be rounded. Yeah, so that rounds to 5. So we're good. So you got to check your answer here. And you don't even have to show your check. Like I just didn't show that one, and that's just fine. So I've got a couple more here. Got 3 more actually. Number 7, the base is 10. The power is 2. Set that equal to 8 minus x. Solve for x. So I have 100 is equal to 8 minus x. You solve that for x, you get negative 92, which you might be thinking, uh-oh, there's a negative number. This one might not check. Well, plug it back in, see what happens. This would be the log of 8 minus negative 92, which 2 negatives make a positive. So that's actually the log of 100, which we know is 2 from before. So this is a valid answer. So it doesn't make the logarithm, it doesn't force it to take the log of a negative number because these 2 negatives cancel out. For number 8, I'm going to have to use some properties of logarithms. So technically this is the log of x squared minus the log of 3 equals 2. And I can't really convert until I get a single log here. So then this would be the log of x squared divided by 3 equals 2. So then the base we know is 10. The power is 2. And so I'm just going to go up here and solve this. 100 equals x squared over 3. multiply by 3, take the square root, square root of 300 would be plus or minus 10 root 3. But the one thing that you have to be careful on, and if you forgot it, you actually did yourself a favor, I don't want negative 10 root 3 because I can't take the log of negative 10 root 3 right here. Right? So if I plug in a negative value, I'm automatically taking the log of a negative number. So don't put the plus or minus on your final answer. Make sure it's just the positive part. And to end this video, when you have two logs that are the same on both sides. So earlier on this problem, we had two logs that were the same, but they were on the same side, so I had to combine them. But when you have two logs that are the same and they're on both sides, it's very similar to this problem right here. When the bases are the same on both sides, you can basically drop the bases and just say 2x minus 3 is equal to x plus 4. Solve that for x, and then check your answer. 7 plus 4 is 11. 2 times 7 is 14, minus 3 is 11. 11 is a positive number, so we're good to go. So this section tends to be a little bit harder for problems like 8 or problems like 6. So I'm really going to recommend either contacting me if you have questions or concerns, or when you're working on the homework, really make sure that you check your work to those or reach out for help. But traditionally, these problems tend to be a little bit tougher than basic logarithmic problems that we've seen previously. So let me know if you need anything.